Hello everyone, this is Sri Chantala. I'm a program manager on the Azure Cosmos DB team, and in today's screencast, I'm going to show you how to set up and demo the Azure Cosmos DB change feed feature for an e-commerce scenario. For those of you who don't know, Azure Cosmos DB is Microsoft's globally distributed multi-model database service, which enables you to elastically and independently scale throughput and storage across any number of Azure regions, while guaranteeing comprehensive SLAs for throughput, latency, availability, and consistency. In this lab, we will be focusing on the Azure Cosmos DB change feed feature, which is a built-in mechanism for getting a continuous and incremental feed of records from a Cosmos DB container as those records are being created or modified. In this lab, we will approach change feed from the perspective of an e-commerce company and see how we can leverage the change feed feature to its advantage to understand user patterns with real-time data analysis and visualization. Today, we will be working with a collection of events or records that represent occurrences such as a user viewing an item, adding an item to their cart, or purchasing an item. When one of these events occurs, a new record will be created and the change feed will log that record. Once change feed logs that record, it will then trigger a series of steps which will result in visualization of metrics, which will help us analyze company performance and the site activity. All the code samples we'll be using today are already available on GitHub at the following link. If you follow the following link, http://github.com/azure CosmosDB changefeed.net retail sample, you will be able to find the entire tutorial along step-by-step instructions on how to set it up and how to use it. Before we proceed, I'm going to quickly go over the different steps involved in the lab today. In the first step, we're going to use a random data generator to simulate a bulk of events which represents a user viewing an item, adding an item to their cart, or purchasing an item. So we have a large set of sample data. Once we have this data, we're going to insert all of it into Cosmos DB and store it in a collection. The change feed will listen for changes to the Cosmos DB collection. So every time a new document is added into the collection, the change feed will trigger an Azure function. The Azure function will now process the new data and send it to an Azure Event Hub. The Azure Event Hub will store these events and send them to the Azure Stream Analytics. Now, we will write queries by which Azure Stream Analytics will process events and build a real-time data analysis. We will then send this analysis to Microsoft Power BI. We will then use Microsoft Power BI to visualize the data analysis we performed in the previous step and build various dashboards so we can see our metrics change in real time. These sample metrics can help an e-commerce company evaluate its site popularity, develop its advertising and pricing strategies, and make numerous decisions regarding what inventory to invest in, and etc. To get the GitHub samples up and running, there are some prerequisites. You will need a 64-bit Windows 10 operating system, the latest .NET frameworks, and the .NET Core SDKs. You will also need a Visual Studio installed and set up, a Microsoft Azure subscription, and a Microsoft Power BI account. Once you have these, you're ready to go. So now we will be using the Azure Resource Manager to create the Azure resources necessary for the lab. I'm going to show you how to do this. So quickly open Windows PowerShell. And once you have it, execute the following command. The command is get execution policy. And then you're going to set the execution policy to bypass. So once you run these commands, it'll prompt you to, hey, are you sure you want to do this? And then just type in Y for yes, and you're good. So next, we're going to download the code samples from GitHub. So just go to the GitHub site provided in the below link, which is github.com/Azure sample/Azure Cosmos DB change feed for .NET retail sample. And from here, you can download the entire code required for the application and the solution. So if you see you have the clone or download option, just click on that and just say download as zip. Yes, save. And once you have this downloaded, we're going to extract the solution and open it in Visual Studio, and then I'm going to show you how to run it. Open folder. Okay, I'm going to extract this here. Yes, extract. And I hope in the meantime you have Visual Studio installed. I just did this before I started recording the screencast. I have a Visual Studio 2017 running, and I also have all the required .NET frameworks downloaded. Okay, so it looks like it's done. Okay, cool. So if you open this, you'll see all the contents of the code sample. And now what we're gonna do is we're gonna open this. Just to show you, you just go and open with Microsoft Visual Studio 2017, and we'll open the solution for you. So this opened the change feed solution. So if you see, it says change feed solution. I opened the change feed solution in Visual Studio, and if you look at Solution Explorer, you should see the contents of the solution and the various code samples. For example, you have a C# class called the change feed processor, and Visual Studio is trying to open this. So yes, now we have our solution open in Visual Studio. So what we're going to do next is deploy all our resources needed for the lab using the Azure Resource Manager. And to do this, go back to where you downloaded the repo and navigate to the Azure Resource Manager folder and open a file. You should have a file called parameters.json. You can just say we can just open with Notepad, or if you prefer Visual Studio, whatever. So we're just going to replace some parameters in here. So for example, you have these blank spaces that says, hey, fill in your Cosmos DB account name. So let's go ahead and enter them. So for Cosmos DB account name, just give in whatever, but just remember what you're giving because you might need it later. So for example, I'm just going to name it. So let's go ahead and give it a name. So I'm going to do is Shri Cosmos DB demo. So you might, if you have like number of accounts there, just give it something unique so it accepts it. Just add some numbers there. I'm gonna keep it simple, and I also need to give it a storage account name, so which is gonna be good. Now that's done, just click save and leave the notepad open or wherever you open this file. So you will need to come back and reference these values later in the demo. So just make sure you keep it open and handy. Next, we're going to deploy all these resources we just named using a PowerShell script. For this, go back to Windows PowerShell and navigate to the folder where you downloaded the repo. So for example, I already did this. So in my case, it was in users downloads. So I went to downloads and I navigated to the folder where I have all the code samples, and navigate to the Azure Resource Manager folder, and here do /deploy ps1. So let's see. So if you do this, it will ask you for a subscription ID. So this is your Azure subscription ID, and you should have this handy. So for example, you can find this in your Azure portal. So if you go to Azure portal, you should be able to find it here. Just type in subscriptions and look for subscriptions. It's going to take you to the page, and then you will have your list of subscriptions. Click the one which you want to use and just copy the subscription ID. Once you copy it, just paste it into your PowerShell. For example, I just pasted in the subscription ID you just saw there and click enter. And now for your resource group name, just give it the name Change Feed Lab. And for the deployment name, just give it run1. So it's going to say logging in, and it's going to authorize you to sign into your account. So in my case, it's So I'm just going to log in. And so now the resources are going to begin to deploy, and this will take up to 10 minutes. So it says starting deployment, and this can take anywhere between a few minutes and up to 10 minutes. So just let that happen. So let's see if you go to home, and then you can go to your Azure Cosmos DB accounts, and you should be able to find, like in my case, I'm using a Microsoft subscription, so there are too many, but you can look for the one you just created. In my case, mine was Sri Cosmos DB demo. So if I open this, it's gonna tell you, it says creating, so let's just wait for this to be done. So once the deployment is done, you will see something like this. Hey, congratulations, your Azure Cosmos DB account was created. So now click on the overview page, and you should see the status of your database to be set to online. That means it's done being created and it was deployed. And in my case, we deployed it to a West US region. So now what we're going to do is we're going to create a collection. So basically, a collection will hold our events, or will hold the events for the e-commerce site. So we're going to build a collection such that when a user views an item or adds an item to their cart or purchase an item, a record will be added to the collection. And this record will have information like on the different type of actions performed by the user. So it will say something like viewed, added, or purchased, the name of the item, the price of the item, and the ID number of the cart involved. So to do this, on your in your Azure portal, go to your Cosmos DB account, and once you're at the overview section, which is where we are, we're going to say add collection. Okay, so now it asks us for a database ID, so we can just give a name. Say, let's say change feed lab database. And we're gonna give it collection ID. Just say change feed lab collection. I'm just gonna copy this. For partition key, we're gonna use the item as the partition key. To learn more on how to select your partition key, please go look at the documentation we have around this. And then for the throughput, for the purposes of this tutorial, we're gonna give it 10,000. And that's it. Click OK. So once that's done, you will see your new collection created here. So under change feed lab database, now you have the change feed collection. So we created our collection, and when we run from Visual Studio, when we run the solution to generate the data is going to be inserted into this collection. I'm going to show you that in a bit. So we're going to get there. Okay, next we're going to copy our keys. So if you click on the keys section, you will see all the different keys. So what you need to do is copy the primary connection string. Just click to copy, and then save it in a place where you will have easy access to, because we're gonna paste these in our code in Visual Studio, so our solution can connect to our Cosmos DB account and insert data. So once you copy this to a notepad, just label it. I'll label it as Cosmos DB connection string, so you know what it is when you're pasting it into your code, because we will be saving a bunch of other keys as well. Okay, that's done. Okay, So next, we're going to get the account key and the connection string for the Azure storage account we created using the Azure Resource Manager. To find your Azure storage account, go to the overview of your Cosmos DB wherever you are, and then click the resource group. For example, I'm going to select the Shri Change Feed Lab, and this will show us all the resources we've deployed in our initial step. So here you should find your storage account. In my case, it's the Shri storage account. So once we get here, what we need to do is take the access keys. But before that, why do we need an Azure storage account? So as the name indicates, it's an account to store data. And for the purposes of this lab, we need a storage account to store data for the Azure function. So the Azure function is triggered when any modification is made to the collection we made in our previous step. And in order for the Azure function to do its job, it needs a place to store its work. And that's where the Azure storage account comes into play. So from here, we're going to save our key 1 and the connection string to paste into our code. So just copy the key and paste it into the notepad you have here. So once you paste it here, just store it as storage connection key, and also, okay, so label the key as the storage key, and you would also need to get the storage connection string, which is also on the same page. So copy the connection string and label it as the storage connection string. And now we're going to get the connection string for the Event Hub namespace, which we've also created as part of our deployment using the Azure Resource Manager. To find your Event Hub you've created, go back to the resource group, which is here, and then you should see your Event Hub. So click on your Event Hub namespace, and what we need is again the connection string. But just to give you an overview, of what an Azure Event Hub is, it's exactly like what it sounds. So basically what it does is it receives the event data, stores it, processes it, and even forwards the data. So in this part of the lab, the Event Hub will receive a document every time a new event occurs. So an event can be anything like a customer viewing an item, adding an item to the cart, or purchasing an item. And once it receives this event, it will then forward that documents to the Azure Stream Analytics. So click on shared access policies, and you'll see something called the root manager shared access key. From here, copy the connection string primary key and save it in the notepad save it in your, I just opened a new one, but wherever you were saving the other strings, just save it as the Event Hub namespace connection string, and you'll be good. So next, what we're going to do is we're going to set up an Azure function with the Cosmos DB account we've just created. So when a new document is created or modifications are made to the current document in the Cosmos DB collection we've created, which is the change feed collection, the change feed automatically adds the modified documents to its history of collection changes. So we will now build and run an Azure function that processes this change feed. When the document is created or modified in the collection we've created, the Azure function will be triggered by the change feed. Then the Azure function will send the modified documents to the Event Hub, which you saw in the previous step. So return to the repository that we've cloned and opened in Visual Studio, which is the change feed lab solution. And in here, go to the local settings.json. So here we're going to replace all the strings or the connection strings we've just copied in our previous steps. So just replace all of this into the fields given. So for example, the Azure storage account key, you will find it as storage key. Just copy paste all of this. Storage key, and then we need the storage connection string, which is this. And then we need the DB connection string. And then the Event Hub namespace connection, which is the last one. So once you're done replacing this, go to the change feed, just say save all, and then go to the change feed processor.cs file. So in this file, what we're going to do is we're going to replace the names with the names we've created. So in our case, scroll down to the database name. So in our case, the database name is whatever you gave it. In our case, it's the change feed lab. If you want to verify, if you go, so in this case, my database name will be, let me check, I don't remember actually. So the database name is the change feed lab database. Just copy this and paste it to the database name here. And then your collection name also will be whatever you gave it, so which will be the change feed lab collection. So copy that, and then we're going to paste it back into our collection name here. Change feed lab collection. And then we need to give, so what is a lease collection? So what we need to do is create something called a lease collection, which you can do manually the way you created the change feed lab collection I showed you in the first step, if you remember. But there's another way to do it, which is to specify something called, we can specify it in the code, which will auto create it. So just give your lease collections a name. So let's just name it leases. So what exactly is a lease collection? So the lease collection coordinates processing the change feed across multiple workers, and a separate collection is used to store the leases with one lease per partition. So once you give your lease collection a name, add this line of code, which is going to auto create it for you, or you could create it manually like I already told you. So add something called the create lease collection, if not exist equals true. And then just save, and then save your file. So now pretty much we've filled in all the details we need here, and we're ready to run the solution. So just click the change feed, run the change feed function which you see on the top of the toolbar, and then your console will appear here. It's starting up the job. Yes, allow access. And so once you see job host started, that means your Azure function has been linked to your Cosmos DB account. And now what we're going to do is generate the data to insert into our Cosmos DB collection. So how you're going to do that is you're going to go back to where you have your code, and you're going to reopen, which is where you extracted it, and reopen the change feed solution in another Visual Studio window. The reason we need this is because we're going to be running two separate programs, and so hence you need two different Visual Studio windows. So I've opened the solution in another window. Okay. What we're going to do now is to see how the change feed processes new actions on an e-commerce site. We're going to simulate the data that represents users viewing items, say, from a product catalog, or adding those items to their carts and purchasing the items and so on. So this data is arbitrary, and for the purposes of replicating data of an e-commerce site would look like. So this is just random. So now to run the data generator, we would need two more pieces of information, the URIs and keys for your Azure Cosmos DB account. To get this, go back to your Azure portal and go to your Azure Cosmos DB account. So, okay, so yeah, this is my Cosmos DB account, and select on keys, and then copy the URI and the primary key. Copy, and again just paste it somewhere. And then we also need the primary key. So just copy the primary key as well. Paste it, and now go back to your Visual Studio solution and open the data generator class. And we're just gonna copy paste this into this. So here you're just gonna put in, okay, so since I've already copied the key, let's just put that in here. Blah blah URI, which we've just, and again probably you will have to put in the database and the collection name. So this we just pasted it here, so you can just take it from here, which is the change feed lab database. And I think the collection name is change feed collection, change feed lab. Cool. And that's about it. So just save this. And now, so here, if you see it points to your change feed function, change it to the data generator and click start. And like, just wait for your program to run. It's building. Cool. So if you see this, if you see the same screen with the stars, that means your your data generator was able to connect to your Cosmos DB account, and now it's inserting random data. So you can see this happen. So if you go back to your Cosmos DB account, and if you go back to your overview, so if you go back to the overview page and look at the change feed lab collection, so you should see the data being inserted as documents. So open your change feed lab collection and look at the documents, and now you will have data in here, or you have new documents inserted. Let's open one to look at how it looks. So for example, here we're looking at a card ID with the number 652 and what the user viewed the item. The item was a beanie and all the other information inserted in the document. So, which is good. And we have like a number of random documents with similar information. For example, this is a men's puffy jacket. All this is being generated by our data generator. So just keep it running. We want a large sample of data so that we can visualize it better in the next steps. What we're going to do next with this data is we're going to set up the Azure Stream and Analytics and then visualize and then find a way to visualize this data. So Azure Stream Analytics is a fully managed cloud services for real-time processing of streaming data. So for the purpose of the lab, what we do with the ASA or the Azure Stream Analytics is we're going to process these events from the Event Hub and incorporate those events into real-time data analysis and send them to Power BI, where we'll create nice visualizations and dashboards. Again, on Azure Portal, go back to your resource group. So in this case, mine is the change feed lab. Go back there and find your stream job. So you see the stream job one, click on that. So what we're going to do is we're going to provide an input to our Azure Stream Analytics and then specify what the output of this is going to be. So if you see, click on your input. And we're going to link the Event Hub, which is going to be the stream input for our stream analytics, and then the output is going to be to a Power BI once it analyzes the data. So say add stream input and select Event Hub as the source. So just give the name as input, as input. Select Event Hub from your subscriptions, select your subscription, Event Hub namespace, which will be the Event Hub name which you gave it. In my case, it's the Shri Event Hub, and then it will automatically populate this because it just had one. And for the rest of the stuff, leave the values as they are and just click on save. And then go back to your stream job 1, and what we're going to do now is add an output or a sink. So in this case, it's going to be the Power BI, where we're going to send all the data which we analyzed using the stream analytics into Power BI. So we can create some nice visualizations and dashboards. So now click on Add and select Power BI as the destination or the sink, and then just name the alias as average price output, and then name the dataset name as average price, table name as average price, and then just say authorize. So now you'll have to log into your Power BI account. Let me do this very quickly. Okay, done. Once that's done, click Save. And now we added our output. So now that we have the inputs and outputs set up, what we're going to do next is we're going to write a stream analytics query so that we can calculate the average price of all the items that are viewed by the users, or the average price of all the items that are added to the user's cart, or average items that are purchased by the users. So essentially this is nothing but a query that's getting you the average price per action. So just click Edit Query, and I'm just going to paste the query I copied from the GitHub repo, which is going to give you the average price per action, which looks something like this, and click Save. Now return back to your stream job 1 and just say start, which will start the stream analytics job. So it might take a few minutes for the job to get started. So at some point you're going to see it go from starting the job to running. Let's see. So now you can see that it says, hey, your job is running. So we're good. So what we're going to do next is you're going to log into your Power BI account. So right now, go to Power BI site and just log in. I'm already logged in. And once you log in, click on your My Workspace. And under My Workspace, you're going to go to Dashboards. And we're going to create a dashboard. Click on Create and say Dashboard. And give it a name. Say average price. That's what I'm gonna name this dashboard. Create. Then we're gonna then click on Add Title, and then select Custom Streaming Data. So if you see under Datasets, you should see a dataset called Average Price, which is what we entered as the output for your Azure Stream Analytics job. So basically the Power BI is the sink, and it's stored, and the table appears here as average price. So select the data set and click Next. And then under visualization type, select the clustered bar chart. And for the axis, select Action. Leave the legend empty, and for value, select average. Oh, see, there goes our average bar chart. Let's just complete setting this up and just give this a name. Let's say average price. Apply. So like you can see the bar chart move in real time. This is happening because as our random data generator is generating new events, and these are being inserted into our Cosmos DB collection, the change feed then is triggering our Azure functions, which is sending the events to the event hub, and these events in the event hub are the input for Azure Stream Analytics, in which we then run our Stream Analytics query to calculate the average price per action, and then the output of this is finally being visualized in Power BI, which is sort of neat because this sorts of graphs are quite useful for, say, e-commerce websites or different stores to decide on what sort of inventory they want to invest in. For example, what's the average price of the items which are viewed versus finally what is the average price of the items that people are actually buying. So they might, based on these data points, they might make decisions on what sort of inventory they want to invest in. So similarly, you can add different sets of stream analytics query by creating different outputs. Just create another output. You have instructions on the GitHub to do this, and you can paste in a different analytics query to get different types of informations and visualizations. So great, that's it. You're done with the lab, and now you see how the Cosmos DB change feed feature works and how it can be leveraged. So I would like to give you 2 pointers while you set up this lab. If you're stuck at any of the places, it could be one of these issues. So the first thing, when you download and extract the zip from GitHub, if you leave the name as it is too long. So when you're trying to build your project, it will complain that the directory name is too long. So when you're extracting the folder, rename the folder to something short. And the second pointer would be if at any other point while you're deploying your resources, or if while you're running any of your 2 solutions, if you see errors or if you're not seeing the events being generated, please go and cross-check that all the parameters that are pasted into our code in Visual Studio are actually the names of the parameters you've given your resources. So if there's a mismatch, obviously it's not going to work. So cross-check these 2 and you should be fine. And if you still have any problems and if you need help, please feel free to reach out. My email address is srchi@microsoft.com. Apart from the tutorials, if you have any questions related to Cosmos DB, feel free to email me, or you can also email the Cosmos DB PM team, who are available at askcosmosdb@microsoft.com, and we would love to help. Well, thank you, and hope you learned something.